Okay, so my name is Uri, and like I was introduced, I'm working on the Apollo team at Meteor. Um, and I'm working mostly on when I started GraphQL, I was working on the Angular integration library. But for a few months now, it's been pretty solid, so all I have to do is just talk about it. So I started working on the GraphQL subscription library, and the WebSocket library, which is how you use GraphQL for real-time updates, on push from the server. So I would want to talk about a lot of stuff, but I still need to do the introduction to GraphQL because most people still don't know what it is. So I'll do the introduction, but I'll try to get to advanced topics as fast as possible. So first I'll start with the basic usage, both in GraphQL in general and then in Angular specifically. Then how do we get to advanced use cases? Like how can we use that inside our components? And how do we manage data inside our Angular applications? And when we'll start talking about managing data, then obviously everyone here has heard about NGRX and Redux and all those things. And I think personally there's a missing link here. Like everyone is talking about NGRX, but nobody is talking about connecting the state with the server. And most of us don't use applications that doesn't work with the data from the server. So I'll talk about that, maybe in a bigger context. And then some people around here asked me to show a bit of how does it work in the server or the middleware, and how we can work with actually connecting a lot of data sources together. So I hope I'll get to that as well. And then the last thing I'll talk about, which this is what I'm working on the day-to-day, and I really hope I can get the time to talk about it, is the real-time aspect of GraphQL and how we can do that today in our apps. So one thing that is important to me is that it's all based, throughout the talk I will talk about, everything I'll talk about will be through two main examples. I'll just show them in really brief. One is that app. This is the more advanced app, and I'll show the advanced use cases in this app. This is GitHunt. It's basically like product hunt for GitHub. The interesting thing about this is that it takes away data from two sources. One is our own database, and another is GitHub's database through the GitHub API. But for the client, it's all the same. So this is one thing that I'll show. And then for a more simple use case, I will show the heroes, tour of heroes, what you all use in your first Angular tutorial, just converted between REST, converted into GraphQL. So those are the two examples. If you want to follow through afterwards, just follow me on GitHub. All my code is there. I tend to less talk in Twitter and more write in GitHub, so it's better to follow me there. So just in general about GraphQL. GraphQL has been around for a while, and the interesting thing about this technology is that it really caught up in really large companies as well as small startups. Like all the companies you see here some of them are startups, some of them are really large companies, and it just caught on super fast in 2016. Facebook open sourced it in 2015. But everyone really caught up, Airbnb, and obviously GitHub. GitHub, I don't know if you heard, they changed their public API. They still support REST, but internally and outside now, their third-party API, you can use GraphQL. There's also actually a small company here in the Netherlands, a really small shop that does Angular and GraphQL. Maybe you heard about this small company. So they're actually using Apollo and Angular 2, or just Angular now. And they're going in production soon. They wanted to tell me, to ask me that I will say that they're hiring, by the way. Anyone from KLM would raise his hands to show who you are? Cool. So you can talk about with them later about personal experiences and how they migrating their apps into GraphQL. So yeah, so it looks maybe for you like a new thing, but Facebook itself has been using GraphQL since 2012 with the first iOS app. And the story there is that they had like this really shitty HTML app. It didn't work. It was a mess. And Google Plus like really pushed forward. Google Plus had a better APIs, better backends, and they needed to move fast. And then they introduced GraphQL so they could supply like a modern API to their modern iOS app, while still using their old infrastructure. They didn't have time to change and migrate their existing infrastructure. And this is probably the reason that GraphQL is being adopted so fast, because you can use your old servers, like whatever you use, IBM WebSphere, whatever horrible thing you're using in your app, you just put GraphQL on top of it, and I'll maybe show some examples. But maybe in general, like why GraphQL? Why is GraphQL better than REST, right? REST is great. Everyone uses REST, and it's just wonderful. So again, I'll talk a little bit in this, when I'll talk about the differences between REST and GraphQL right now, I'll talk about this context. This is the same app, GitHunt. It has different components, and for here, for example, it renders a list of different repositories from GitHub, and the list of issues and like developers and a lot of information on that. Now, how would we implement that? So if we use REST, like regular REST, first thing we would do is we would call to fetch all the repos, right? All the repos that we want to fetch. And then we'll get that information. But then we need to fetch again all the contributors for each of those repos. And all the, like, if we have like 100 repos, we'll have 100 requests. Another thing that is a problem here is that like the endpoint is not adjusted to just what the information we want to get. So usually if you'll get the repo from GitHub, you will get a lot of information. And when I'm saying a lot of information, it's really a lot of information. This is true information from GitHub. So, but you would say, like the architects in here would say, will come up and scream, yeah, but I just can create another REST endpoint for exactly the type of use case that I need with just the data that I need. Well, that's okay, but what will happen then is now, what will happen, your app uses several like new server endpoints, and now you coupled your server implementation with your client. If your client now needs another field, you need to go to your server developer, and now you need to ask him, oh, I need this another field, and it usually will take a while. And then maybe you want to remove a field, but then you don't also know what other clients are using the same endpoint. So this is not a solution. This is something that will always be there, the tension in REST APIs between having like a generic REST API with all those things that you will do multiple requests to, or just have specific API that you need every time the server developers and the client developers to work together and not separately. And there's another thing. Like you now call a REST endpoint, and you get data back. What data you will get like 2 weeks from now or 2 months from now? If someone will change the backend API, you will get a different API. You don't have any guarantees that what you're going to get, and it's going to break. And it always breaks. It always breaks. Like stuff that works right now, always, as front-end developers, we rely on that information, and it always breaks. So the good thing is that Facebook probably had the same idea, and they came up with GraphQL. So GraphQL is a query language which basically separates the two, the client and the server, saying the client asks for what it needs, and the server sends only that information. Let's just look at like a regular, a simple GraphQL query. The top, this is how a GraphQL query looks. I'm asking for a hero. I'm asking the name of it, and I'll get the name of it in exactly the same structure. I'm asking for, later on, the height. I will get the height in exactly the same structure. If I remove them, then I won't get. I'll get just what I need, and this is without changing anything in the server. Now, another interesting thing here is that it doesn't matter how nested my request and my structure is. Like here, I have a hero and a name, and for each hero I get the friends, and for each friends I get the name. I'm sending it to the server. I'm getting everything in one single response. No multiple, so no overfetching, and I get exactly an all in one single request. And the interesting thing is that each field could go to a different data source. I could, like I'm doing with the example that I'll show in a few minutes, some of those fields are going to GitHub, and some of those fields are going to my internal server, and some of other fields are going to a third-party API. The client doesn't care. You will get exactly one single response. You don't need to do joins on the client anymore, or wait for and like handle all the requests that are coming. Another very powerful thing, this is the fact that now at rest, we don't know what will come up. In GraphQL, we have a schema. The schema basically describes the data that the server can reflect to you. And all you need to do is choose those fields. Now, you will have a guarantee that you will get those fields and they will be in the type that they're supposed to be. The name will always be string. And you have a guarantee for that. Your code won't break after 2 months. If the server will break the code, the server will break the code. And the server builds won't pass, not yours. And that gives you also a lot of features. Like here, I don't know if you can see, but basically you have auto-completion on your query on your client. And validation. And this can be even before the server even implemented anything. This is just from the schema. You can just build a schema and that's it. Off you go. You don't care how long the server developers will get there. And more than that, there's like libraries that in one single line of code will give you mocked data according to this schema. So really, you can really separate the client and the server development. I'll show a little bit of some like really specific examples for GraphQL itself. So those are mountains. This is the app. And this app this is the front end. I already built the front end, but let's say now I'm a new developer or I haven't built the front end. This is the graphical. This is an editor that I get just from writing the schema. So if I'm a client-side developer, I can just specify here what I want to fetch, and I will get it. And more than that, I'll get all the possibilities for the things that I can query, all the queries. Like I can query a feed, I can query an entry, which each entry includes a repository, a score, whatever I want. So before I even start developing, I can just go here and write, let's see what we have on repository, for example. I'm going to repository. Repository has a name and it has a description. So I'll go here. I'll have autocomplete. I'll get it here, and then I'll get the description as well. But there's also variables. So I can just limit that to 1, do pagination with it. Or there's types of feed. So I can go here and look, what is a feed? What is a type of feed? I just click on it. And I have hot, new, and top. So I'll just change it to top with autocomplete as well, and I'll get only the top 1 or the top 20. And then it will take longer, but it will work. And every time, no matter how nested I'll go, it will all be in one single response. And this is for free. You haven't developed, we didn't install like a documentation framework or didn't have to maintain it. It will always be up to date, always. And just an example of how nested you can go. This is, by the way, the GraphQL.org website. It's a great website to start. I have a graphical running inside the browser here. Maybe I'll increase the size. And I'm querying for a hero and the friends of the hero and the name for each one of them. But then for each one of them, I can query their friends and the name. And I'll get everything in a single response in the structure that I need. And let's go deeper. Again, friends and their name. And I'll get it again. Yeah, that's a good question. What happens if we're doing something wrong, like wrong field? I'll just get an error. And I'll get this error before I even did anything with the server. Maybe the server doesn't exist at all. So this is very powerful, both in terms of how fast we can develop as teams, and both in how the experience we can give to the users. Think about, we're talking about rendering super fast, and all the apps will be super cool with super animations. But then if we're calling the server 10 times instead of 1 time, none of our experience will be good. So this is an important thing to note. So this was a bit about GraphQL. The important thing about GraphQL that I mentioned a bit is that let's say we have an existing code right now. We have existing services. We have all databases that we don't want to change, but we want to build a new Angular app on top of it. So we just put a GraphQL layer middleware on top of it, on top of any data source, and we'll get all of that and we'll get all of that on top of our existing servers. We don't need to rewrite our servers at all. I'll show that in a second. But so this was a bit about generally about GraphQL. Probably some of you already knew those facts. But let's talk about the client, because we are Angular developers. And let's start with a simple way to just use it with Angular. So I'll just show you. First of all, if you want to know where to go, I just go to the mountains and then look at the Angular I/O website. I PR'd the website to include a cookbook for GraphQL, which will take you step by step on how to take basically, it will explain a bit about GraphQL, what I'm doing here, so you don't need to do that. But then it will basically tell you how to use GraphQL in your Angular app today. Step by step, it's pretty simple. And the example here is based on Tour of Heroes. So let's look a bit about that. So we have the Tour of Heroes app here. Now, everything is the same, just here we're talking about GraphQL. So when I'm rendering it here, then instead of going to a REST endpoint, I'm fetching a query. Let's look at it. All right. I'll try to show you here on the Apollo GraphQL tools. And we have a query here. Now, this query sits inside of our app. So this is basically how we describe our data, right? It's pretty simple. We want heroes, and we want all of them, and we want their IDs and a name. Now, we can already just click here and have the same editor, graphical editor that we saw before inside our app, run it here, and get the results. And those results are inside our app now. It's not like a general thing. And if I can test it out, I can remove some stuff, let's say, those 2 fields, query that. Then I can just take this query, and how do I get it into my Angular app? That's it. That's all. If you remember the GraphQL, the Tour of Heroes example, there's get heroes, and then you call get heroes. Here, you paste this query that we do anyway. Just paste it inside the watch query argument. The same basic thing. I can specify what I want to get: the name, the ID, or just one of them, or maybe new fields. And then I'll get it as an observable and a data that I can render. Now, I'll get it as an observable. This is like a simplified, maybe I'll increase it a bit, but too much. But this is a simplified example because I'm getting an observable here. I can just render it with the async pipe to the template. But this is just to show you basically just a simple use case. So yeah, just to start, it's very simple. You do npm install Apollo Angular, and then you add this thing to your app, and you're done, basically. So this is the simple use case. But once and that's fine, you know. We already gained all the things that we talked about with GraphQL. We have a separation with the client, and with the server and the client. We get everything in one request, and we can just change the fields that we get. We don't need to overfetch or underfetch. And that's fine. But GraphQL with a client gives us many more capabilities on just fetching stuff like we do with REST. And I'm going to talk now, maybe I'll dive deep, like it's a bit deeper or like more advanced subjects. But those are the things that you can use today, mostly even without doing anything, just installing Apollo client instead of using just like a regular GraphQL query over HTTP. So, okay, so we have, our apps are built out of components, right? Everyone is talking about components, everything is fine, you know, and components are great because, you know, they're just a small piece of code that we can reuse and move them around our app, right? We can reuse them, we have a clear separation, and it's fun, you know, it's good, and everyone is doing that. But what happens when we call the server? How do we keep that encapsulation? So there's a lot of like solutions out there in the Angular world. I'll show here why those solutions fail to encapsulate the concept of components. So the one option that we have when we call the server is basically just to do an HTTP request from the component, right? Each component will call the HTTP request that it needs. So we import the HTTP service, and we send an HTTP request, and we get the information back, and we render it. That's fine. But what's the problem with it? We have multiple components on the screen. Each component is querying different types of fields, different endpoints. And maybe some of the data is combined. So we're going to query multiple times the same data over and over again. Another thing is that we have two components basically can query the same. They can query the same endpoint. And what if one component changes? What if we move another component to a different place? So we get the problems that we get with REST that we talked before. But nobody's really doing that, right? Like what we actually do is we put a service, right? Everyone is using a service, and we just, in our component, we import the GitHub issue service, and we just do get issue from the service. That's great. Like that's the way we do it in Angular, right? Well, there's problems with that, right? Now we have like multiple components. Some of them call the same service, the same function. What happens now if I'm changing one component, and now this I still like use that service in other components, or I move it around. So we're not encapsulated anymore. Now we have like single point of failure, and those components are not really separate from each other, and they can't do whatever they want. And we have no idea how many components are there. And now if there's another route that we go to that also calls the same endpoint, if we'll change that code, it will break all the other components that we don't even know about, and basically it will fail. So that approach is not that good. But then there's a third approach, the approach where, because we're now using components, right? So we have a component tree. Maybe we can just populate the data dependencies on top until we get to the parent, and then just query from the parent, right? Like we have 3 components. Each component is like exposing what he needs from the parent component, and the parent component, and then the top parent component will query it from the server. That's fine, but when that child component will change, that change will now need to propagate to all these parent components until the top parent component. So not so reusable, right? So yeah, there's problems with how we fetch data today. We just need to first, it's like an addict. You first need to acknowledge the problem. So now that we acknowledge the problem, maybe let's talk about the solution. So with GraphQL, because of its nature, because it's a static query language, what we can do is that we can describe the bits that each component needs, and then have a client, a central client, a central store that will basically understand there's a render right now, will merge all those rendered components into denormalize those queries into one query for the server, and we'll fetch that in one request. So what we gain here is that when we change one component, we just need to change one component. We don't need to change the parent. We don't need to change anything else. Let's see how it looks. So we have an issue. I darkened the not important part, but there's a template that renders the issue title. And with the query, we request ID and a title. And it's the same file. But then, if we want to now add a new field, created at, the only thing we need to do is just to add it in the same file, and that's it. We didn't change anything. Not the parent component, not the central service, not the server, nothing. And this is because of the power of a static query language. Another thing that I touched a little bit before is its performance. So again, we can take all of those queries in a render tree and send one request to the server and get one response. And when we move to another route, we can, again, send a request and one response. OK, I don't have tons of time, so I'll continue to more advanced stuff. I know it's a lot of information, but then there's a lot of more simplified talks that I'm talking about GraphQL and Angular, and also you can always look at the YouTube and slow motion me. So another thing that people ask is, how do we change the data, right? Like post request in REST. So first of all, mutations are possible, but they're also more powerful. I'm talking now about just the simple GraphQL. I'm not talking now about any client. This is a GraphQL mutation. Basically, it's a function. It's so this is a GraphQL mutation. Basically, it's just a function that takes parameters. Now, create review. So I'm telling the parameters what review should I create, and the review itself. And that's nice. But unlike REST request, when I'm doing a post, and then I'll get from the server 1 or true or who the hell knows what, this time I can define what the response would be. I asked to create a new review, and I'll get back this structure. So I can just get this information back when it's done and push it to my list. I don't need to do another request to the server. I know exactly what happened. If there's errors, there's defined way of getting those errors. So this is very powerful, and this is just GraphQL. But if we're talking about clients, so that's what we did right now, right? Let's do it in Angular again. We request a change from a component, and we just go directly to the server, right? And you'll copy paste this the same query language of the mutation. You send your variable in, and you're done. And this is basically like you do post requests today, but a bit more powerful. But let's think about it for a second. I'm changing data. And I have a central store if I have a client. So I have this data in the central store. So I'm changing the data first in the central store. Then I get it from the server. And then if there's other components that also use the same data, they will change as well. This data will be synced between all the components that are rendered without them knowing about each other. You don't need to take care of syncing this information. So this is a plus that you get when you work with a GraphQL client. I know it's a bit more advanced, but those use cases are very common. Think that you have multiple components. One component do post requests and get a result. There's other components that are with the same data, and now it's not synced anymore. I'm sure a lot of you have gone to this problem. So you don't need to take care of this problem anymore. But then we can do even better. Right now, we're sending it to the server, and it takes time. But we have a central store. So what we can do is we can first send this request and immediately change the store and immediately sync it with all the other components. So it will be instant. The user won't understand that there's a network. It will happen instantly. It would look native and fast. And your users, by the way, expect that. Even if you're now putting a spinner, it doesn't help. So, and then you will get this post request will get to the server, will come back, and then we will update those components with the real data. So this is another very important use case that you will get when you use a client. Here is just like an example. There's the right part is the one that I'm doing the change immediately in the store, and the left part is how you do it today. So think about how your users feel. And your users use those types of apps in the right all the time. In Facebook, Airbnb, they expect that. The fact that you don't use it and you put a spinner doesn't really help. So how do we do that? We just need to do the same thing that we've done before, but we have another field. The Apollo client supplies this field called optimistic response. Basically means if you're optimistic and you think this change will work, this is how you describe the data. And again, you just describe it in a JSON data, very simple, in the structure that you expect, and that's it. We will take care of overriding it if there's an error or if there's a new response from the server. So that's cool. We understood now that there's the network thing where we request response from the server, and that's we can do much better with GraphQL. And we understood we can use a central store, the data that we already have today on our apps, to work with to make those interactions better. But the central store is basically what we keep hearing in NGRX and Redux and all those cool talks, and it's cool stuff. But what is a state of a client? Basically, most of the data that sits in NGRX, most of it, not all of it, is data that comes from the server. So now that you have a central store that already manages all the data that comes from the server on your local store, why do you need another store? So I have a local storage here, right, using GraphQL, and then I have another store, like Redux or NGRX. Why? Because, why would I do that? Let's think about, so what we understood in Apollo is we basically realized you can't really separate those two. There's some stuff that you need just local store without the server. Mostly those are stuff inside your component. And then your component doesn't use NGRX. But most of the stuff that you put in NGRX, other than routing maybe, is derived from the server. So what we did is that instead of now for you learning another way of managing your store with reducers and all those stuff and actions, we do that for you. We use reducers and actions underneath the hood. We use basically Redux inside Apollo client, and we give you an API, which is exactly the same API that you use for fetching your network and describing your components data to manage your central store. So you can see here, you can just read query. Read query doesn't go to the server. It goes just to your central store. And it's already the language that you use. So you can just read a query, and then you can write a query. And again, it's just like the same thing that you've done with GraphQL for the server, you do it for your local store, doesn't matter. And we give you a lot of things to help you manage that, but if you want to dive in and you want to mess around with the NGRX or the Redux, you can do it like that with the same language. You don't need to learn another new language of managing the local state, which usually is totally it's actually just a subset of data that exists on the server. So with those things, we can actually give you a possibility not to just define the optimistic response. I got a request from the server. I sent a request for the server. I think that this will work. Change the store now. I can also do change the way that I handle the response. Now, which is what you do in NGRX. You send an HTTP request, you get it in, and then you push it to NGRX store. Here it is, with just GraphQL. The update method is a method that we give you. It basically says, now you got a response from the server of your mutation, of your change. This is the old data, send us the new data. This is the old data, this is the new data that arrived. So you just merge them together or do whatever logic you want. If you just merge them together, by the way, we can do it for you. You don't need to write all that code. But if you do want to write the code, you can write whatever you want and do whatever logic you want. So I talked a bit before about, so this was a little bit of more maybe advanced subject, but maybe just to give you a context of NGRX and Redux, with everyone is talking about it, but nobody is thinking about the whole architecture of their apps. There's not a lot of apps that don't call the server, like Angular apps that doesn't call the server. So another thing that I mentioned a bit is that the fact that it's a typed API. So most of you probably asking, oh, TypeScript. I use TypeScript. So first of all, just think about the logic. You use TypeScript to make sure everything is working inside your app, but you don't use types when you work in the server, which is you don't have any control of it. So you probably wished you have types for the server. So this is it. And the interesting thing is that there's a lot of tools out there that you can just generate GraphQL TypeScript types from GraphQL. So you can just use those types, and it will autocomplete whatever you need. So I don't have a lot more time, but but people ask me to talk a little bit about. Oh, I have 10 minutes. That's actually a good. That's good. Thank you. So I talk a little bit about the server. It's more, if you're just a client developer, you can listen, so you can convince your server developers why they're wrong. So the interesting thing about GraphQL, like I said before, is application query language. So when someone asks, you go to your, like a lot of people are asking me, wait, so GraphQL works with like X, GraphQL works with IBM WebSphere, GraphQL works with Postgres, GraphQL works with whatever? The answer is always yes. And why is the answer always yes? Why you can put a GraphQL API over everything? It's because the way it's structured. On the server, and maybe I'll show like quick code, on the server, each field that I request is basically a function. In that function, I can call, maybe I'll show you really quickly something. I'll show it here maybe. I have an in-memory database, which I use for the Angular stuff. So basically, I need to resolve heroes. If someone asks for hero, oh. I just love mountains, that's all. So basically, I need to resolve in the tour of heroes, I need to fetch heroes, and I need to fetch a hero. And I need to update a hero and add a hero and whatever. With GraphQL, I can just resolve it as a function. And in that function, I can write whatever I want. So I can write here, like, this function basically just do it in memory. But I can just do like http.get and then just send my old server like /get hero, right? And then I just put it on top. It's stuff that I do anyway on my client today, but now I'm doing it in a middleware. I'm not wasting network errors, and I get a schema over it, and I can always now change the data on top. Because tomorrow, if I'll see that this is slow, I can just change it into something like, I can like comment this out, and then I can do something like db dot, I don't know, query or find, and then like, I don't know, heroes, whatever. You get the hero and ID, right? Like I can put any code that I want here. It can be an ODB, it can be an XML request. Actually, like someone I worked with created a thing that you can generate a GraphQL schema from XML files. So yeah, the answer is you can do it always, and you can query anything you want. yeah, any backend, any client, any language. There's complete separation. You can use Angular, React, jQuery, whatever you want, iOS. There's native implementations. It's basically, and this is just like a small list of libraries for PHP, .NET, whatever you want. So no excuses. Okay, I have like really short time now, so I'll talk about the stuff that I'm doing right now in the day-to-day, real time. So we covered a lot of use cases. I know it's a lot, but there's another use case we haven't covered. What happens if we have a client, they're running, and something happened in the server, and the server wants to push data for the clients, the other way around? How do you do that with REST? There's some like hacky stuff, but it's not built in the language. Well, with GraphQL, you have a built-in implementation for GraphQL subscriptions. It's a way to do subscriptions over WebSockets, for example, or whatever network transport that you use. I'll show you a quick movie that I've done for a blog post I'm publishing tomorrow. Basically, this is graphical, like you saw before. Think about it as a chat app, right? And basically, the thing that I want to do now, I want to know when someone posted a comment or posted on the chat, but just on a specific topic. This specific topic is Apollo client, for example. And then I'm telling what I want, like what information I want. The transport is basically opening the WebSocket now. And then when I'm writing hello and I'm submitting it, it's instantly pushed into my client. And again, as a client, I have the power to say how that push would look for me. The information here I defined as a client, not the server. So I just need to decide what to subscribe to, and then get the information. The server exposes the subscriptions that you can expose and subscribe to. And yeah, and you can use it today, and that's basically what I'm working on right now. So this is another use case that also your users expect, and probably you don't do it today, or you do it in a hacky way, or like not standard way. Okay, so to summarize the whole stuff that I've said, let's summarize like maybe something more basic. GraphQL gives you type safety between the client and the server. It means that you don't need to worry about anymore what will come from the server. You define it in advance, and the client developers can go develop their client, the server developers can go develop their server. Now, it's something that was promised to us many years ago by all kinds of technologies. I know because I tried all those like weird technologies. This works. Try it. It empowers product developers because I can just change stuff in my client, and I don't need to be dependent on the server. Just remove a field, add a field, I'm fine. And the backend developers can just do the thing they want to do, expose data. They don't need to care about a new screen on the client or a new design or a new app. So for a summary, we used to have a page-based apps. Now we have component-based apps. Everything is a component. We need fast rendering so our apps would look good, and we want to separate the client and the server. So we need a component-based API. We need a single, to get all the information in one single request, and we need to go GraphQL first, which means we start with the schema, and the two teams work separately. So I know it was a lot of information, so you can just, all those examples, the GitHub examples and the tour of heroes, it's all under my GitHub. Just go and check it out there. Also, you can start with the Apollo client website. There's like how to get started and all the information that you need, like all kinds of examples in whatever you want. Even if you use iOS, you can do that. Yeah, thank you.